So let's look at a few more electron configurations, give you a little bit of practice working through these. First one here says draw an Aufbau diagram of the first four energy levels, which you can do by looking for an Aufbau diagram. Again, when you're doing these electron configurations, I'll always let you look at an Aufbau diagram to do them, but there is a trick for recreating them. So if you make a column of all of the s orbitals, 1, 2, 3, 4, 5, 6, and then all of the p's, of course, remember there's no p sublevel in the first energy level, so you have to start on the second line there. There's no d sublevel in the second energy level, so you have to start on the third line. And then draw a series of diagonal lines through that those rows of numbers. And so the diagonal lines tell you the order in which electrons are filled. So we start 1s, go through that second line, that's 2s. Third line is 2p, and then 3s. And then we go 3p and 4s. And that's the bit that shows you that the 4s is actually going to fill before the 3d. And then the 4p, 5s, 4d, and so on. So with that Aufbau diagram in front of you, maybe you'd fill out the Aufbau diagram. You might make two of them in your notes and get the arrows in there using the three rules for phosphorus and for scandium. Go ahead and pause the video and do that. You want an electron energy diagram, so that's arrows in the boxes, and you want an electron configuration. That is the 1s, 1s2, 2s2, the line of letters and numbers. So go ahead and pause the video. Electron energy diagram and electron configurations for both phosphorus and scandium. So let's go ahead and look at the answers for those. Here's the phosphorus electron arrangement. Again, you're going to have 3 electrons unpaired in the 3p. They could either all be down or all be up. That's Hund's rule. Filling orbitals of equal energy, you fill with 1 electron in each orbital with like spin. Again, so those could have been all up. But in the electron energy diagram, you have to show the arrangement of those electrons. Electron configuration, 1s2, 2s2, 2p6, 3s2, 3p3. Scandium would look like this. 1 electron unpaired in the 3D. Everything below that is filled. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. And again, we leave that 3d on the end rather than move it back with the rest of the 3's because it's not filled. Had we started to move into the 4p's, that 3d10 would have to be moved back with the rest of the 3's. Okay, so here is another chance for you to take a practice at this. So just look at the Aufbau diagram. You don't actually have to put the arrows in. Just count boxes until you get up to however many electrons are in each of the atoms. Make sure you arrange it so that all of an energy level, if it's filled, is together. So go ahead and write those 5 elements down. Look at your Aufbau diagram. Write out your electron configurations. Go ahead and pause the video, and we'll put an answer key up here in just a second. And so if you want to, again, pause the video, you have the answers here. Go ahead and check through all of your answers, see how you did there. Make a note of anyone that you can't figure out why you don't have the right answer, and that'd be a good thing to shoot me a question on. Okay, so let's take a look at another setup. So let's do one more of these. So do an electron configuration for argon, and then go ahead and pause the video and put that up there. Okay, so there's your electron configuration for argon, 1s2, 2s2, 2p6, 3s2, 3p6. And then we have something we haven't seen yet. So that's calcium 2 plus ion. It's a cation, it's positive charge. So think about how many electrons that would have to have. And then write out an electron configuration for that calcium 2 plus cation. And maybe you see that there are some similarities there. What we call this, when you have 2 different particles that have the same electron configuration, this is referred to as isoelectronic. Real quick question for you. Some people ask at some point, what do the SP, D, and F stand for? And then what comes after F in the energy sublevel series? So again, we've said that the number of sublevels is equal to the energy level. So the fifth energy level ought to have 5 sublevels. Turns out you would need like 200 electrons to ever get into that fifth sublevel for the fifth energy level. So we don't ever write it because you never fill anything bigger than an F. But just as a side note, we have sharp. So these are terms for mathematical equations. The S sublevels are referred to as the sharp equation. P's are the principal, D are diffuse, and F is fundamental. I have no idea what those mean or why they mean that, but there they are. S, P, D, and F are the sublevels, and then after that it just goes on with the alphabet. G, H, I, J, K, L, M, N, O, Q, right? Because we're going to skip the P, we already have it. G sublevels look like that or like that. And again, those donuts are in the places where the other donuts for the D's and the F's are not. So that's just a little side note piece for you and a little practice with electron configurations.